So you'll see it's pretty cool. But for Rhino, when you first open it up, it asks what template you want to use. Typically for architecture, what we do is large objects and feet. So what this does is it'll choose your units for you. So when you move something by 1, whether that's 1 foot or 1 inch or 1 centimeter or 1 meter. And then the other part is the difference between large and small objects is the tolerance. So notice that here it says it's a 0.01 absolute tolerance right here. If you do small object, it's going to be a tolerance of 0.001. It doesn't sound like a big difference, but it's a huge difference when it comes to modeling. So if you accidentally start a small object, you're going to have way more. So like whenever you try and do a command, it's going to go to like way more decimal places, because Rhino is really oftenly used for like jewelry and stuff that like the total model is like this big. So if you had a tolerance of 2, like that's like bigger than your whole model. So they need a much tighter tolerance, and they can go even tighter than that. So typically for what we do, large object feet is enough. So I'm going to start with that one. And if you like working in inches, like the way CAD is automatically set up, you could do large objects in inches. So I'm going to do feet to start off with. No, I guess it made like a default one. So the first thing you'll notice when you open Rhino is you get 4 windows, which is different than most other software that we've been using up to now. So this doesn't mean you're doing like 4 times the amount of work. It's just you have 4 cameras that are showing you the same space. So if you look in the top corner, it tells you kind of what view you're looking at. And then if we make something, so if you come over here where you have this blue box, you'll notice here you have a bunch of tools. If you click this little arrow, I'm going to make something that's not symmetrical. So something like this. I guess they're all symmetrical. But if I come over here in this space and click and make this little pyramid shape like that, you'll see that in all the different views you see the same object. And if you click on it, it'll highlight yellow, and then you can move it around. Another thing that you should check out is along the bottom you have a bunch of options, and then along the top you have all these little tabs. So if you're looking for a command and you don't see it, make sure you're not on the wrong tab or something like that. And then along the very top you have all of these, which are grouped by what it says at the top. So if it's going to control a curve or a line, in Rhino, lines and curved lines, whether they're straight or curved, they're called curves. And then if you had like a point or something, that's just called a point or a vertice. And then once you get into surfaces, you have all these surface tools, you have all the solid tools, and then all the mesh tools. So when we start looking at how Rhino is set up, you'll see that it has way more variety in the type of geometry you can draw than you could in SketchUp. In SketchUp, everything is polygon based and is based on those little triangles. Rhino doesn't need those triangles. It can work a lot differently and a lot more fluid. It can also create that type of geometry with all the polygons, and that's considered a mesh. So if you find like a mesh geometry, think of that as something that's been modeled the way it was in SketchUp, where it's all faceted. Whereas a solid, in Rhino you can actually have a solid shape where like a block of metal has metal on the outside and metal all the way through. It can actually treat objects like that. So if you carve away, it's going to be solid. It's not going to be like in SketchUp where if you have a box, it's really a bunch of like thin planes all enclosing a box. You can have that in Rhino, but you can also tell it it's solid. And so that makes a big difference in some of the commands. They work with solids, some of the commands prefer planes, some of them only work on curves. So you'll be trying to do something and it's not working, or all of a sudden part of your model flies off into space, and it's because it was only grabbing either the edge or it can't adjust itself to change a solid versus a plane. So that's something that immediately start thinking about, is that you can have different types of geometry. And when you click on something, if you look here under like this tab that you have over here, the type of object, it tells you it's a closed solid poly surface, and you're just getting cut off. But this will always tell you what type of object you have. So let's say here I make this on the ground. If I pick that guy, it's a closed curve. This one is a closed solid. And if you grab both, it will tell you varies. So that's another way to know what type of geometry you have that you're working with. If you notice right now it's all wireframe, and you can change that real easily by going to the little triangle next to the name of the view, and then you have a bunch of options, and these are primarily for the view, and they're only going to affect the view that you're changing in the moment. So if I change this one, it's not going to affect this one. So if I go to shaded here, you'll see it drew it like that. And then if you right click, that's your orbit, and depending where you click, it makes a difference. So once you start modeling stuff, you'll see there's this weird thing that happens with Rhino. It's better with Rhino 6. With Rhino 5 it would happen all the time, but once you start getting a bigger and bigger model, you'll realize that the center point of the orbit is not around what you're trying to orbit. And you're trying to orbit around this object, but then the camera tends to try to orbit over here, and you end up not looking where you wanted. So in order to kind of get away from that, you can select objects and then tell it, this little guy looks like a magnifying glass with like a peanut inside. So that is going to zoom selected objects. So once you do that, your camera will zoom there, and it also resets your orbit so that it always centers around those two guys. The other thing to keep in mind here, for now I'm going to make my screen just one view so that it's a little easier for you to see what I'm doing. So to do that, you can just double click on the name perspective, and it should full screen this one. And if you want to get back, you can double click on it again, or you can use this guy here, which will restore your viewports. You can also stretch these like this and make them any sort of size you want. So if you wanted to be able to always see the side of your model but not lose it from here. And then one thing before I move on, you'll notice that when you highlight a button, the default is to left click, and it'll tell you what it is, but it also shows you that if you right click, that's kind of like a general rule, it will apply the same thing to all of your views. So if I click only once here with the left mouse, it will zoom. Right now I'm in the right view, but see how it zoomed that view? If I click into this view and I grab my objects and I click it, it will only zoom that one. But if you right click, it will zoom all your views. See, it made it fit into all of them, regardless of how big they are. If we do this, it's going to zoom them all to fit in there. And then that's something that's really cool, because sometimes you're trying to work on something and you want to see it in all the different modes, and you just right click on that one button and it does all the cameras at once. So that's just like a really simple thing. Another really good tool, so let me make this one. Oh, and if you want to go here, if you click this one, it will default you to the standard for views. And if you right click, oh, you can change these, so that's what the difference is. So I can make that right view, or I can set this one to be like a totally different thing, like if you wanted a isometric view here, and then here I can make this one like 2-point perspective, and we can zoom that one out. So if you wanted to go back to the original 4 views, like the top, left, side, bottom, that's this guy, and you right click on it, and then that will reset all your views to go back to what they were originally. For some reason that doesn't look like the right view. There you go. It was just loading. So one thing you'll notice here, let me make this one bigger. So this is called the Gumball. So see that little guy that appears in the middle of your selection? And that's super useful, and you turn that on right here, because by default it's not on, but then if you go down here and you click this, it turns it on. You'll notice if you know AutoCAD, a lot of that will kind of overlap with Rhino. It feels very similar to AutoCAD in that sense, except it's 3D, because you have the same kind of, you can do like your snaps, you can do your movements, you can type in commands. So it has a lot of similarities with how you operate within the CAD environment. What this lets you do is it lets you, it's actually way more powerful than it looks at first glance. It just looks kind of like a little like weird thing in the middle, but you'll notice as you move around that the options kind of change and things start moving around. So what this does is if you grab that the red arrow, it's going to move your objects. Oops, I think I missed it. It will move your objects in that direction. And then if I move it back that way, it'll go there. I can go in the vertical direction. And where this is really useful is sometimes in perspective it's hard to tell what's going on. But if we look at this like that, as you move this up, notice how in that top view there's almost no change, because at that perspective where you're looking straight above, we're moving straight up and down, so there's no change. Whereas sometimes when we move this way, see these two views are moving, but that bottom left view isn't, because we're moving straight at that camera, so there's no difference in that sense. So that's one of those things where if you look as you move around, you get these little squares, and they're colored in the same colors as the axes that they represent. So this would let you move in both green and red, but not vertically. So your object would be locked to that plane, but it would still move like that. So see, it can move around, but it's always going to stay flat. Whereas if you move down this way now, we can move it in that plane, but it's not going to come towards us ever. So that's just a little thing to kind of be aware of. If you look, you also have on the back side a little arc. So here this lets you rotate in that direction, or you can rotate in this direction, and you can always kind of choose different ways. And then I think Control Z will undo. So let me move this guy up a little. And it's a little trickier to see, but if you can get, if you look, like the arrow ends there, and there's like a white dot, and then there's a dashed line that comes off the back, and then there's a square on the other end. That becomes your scale tool in that direction. So if I click here on the green one and start dragging in, see how I'm scaling it in that axis? And then if you grab that one, you can do it in that direction, or you can do it vertically. So it has a lot of functionality built in. If you can click, it's really hard to tell here, but there's like a little white ball there that's just off of the center one. And when you click that one, you get options. And you can, the first one is relocate the gumball. So let's say I wanted to rotate, but I don't want to just rotate around this center point. I want to actually rotate around this line that's down here. So I could relocate the gumball to be here, like there, and then align it like that. And now I can rotate our objects around that point. So see, like this has a lot of power. And then up to now I've only just been randomly clicking and just dragging, so it's not very precise. But if you did want to move it, let's say a special like amount, or like 10 feet, you can click one time. So right now we've been clicking and dragging. Instead of doing that, just click once and you get that little window that pops up. And now you can type in 10 and hit enter, and it will move it 10. It's 10 units, but our units are in feet. If you notice the grid in the background, that's a 1 by 1 grid. So that's 1 foot by 1 foot. So when you're looking at something, oops, I was trying to orbit and I clicked the mouse button. That's one thing you'll notice. If you click the wheel, you get this little menu. And the default is to save, like right in the middle. So all the time when you're trying to orbit, you'll accidentally save your model like over and over. So that happens to me all the time. But those are like the most key things. Also down here you have your like Ortho Lock. So if you do O snap, that's not like it's getting sassy and saying like, oh snap, it's object snap. So that is what allows Rhino to know when you're trying to snap to objects. So see here I'm on the endpoint over there, and right here you get all these different locks that you can either snap to or not snap to. So if you turn off O snap, it'll say disabled, and you turn it on here, and then the Ortho Lock is here. So now you can only really draw or move things in perpendicular directions. So it's just like in CAD, and it actually has the same shortcut, which is F8, which is nice because if you're used to the CAD shortcuts, a lot of them are exactly the same. I think F3, no, it doesn't do it. F3 in CAD is your object snap, but it's not here. So F8 will give you ortho, or you can remember to look down here. Another thing we can do, oops, I just did it again. See, I saved. So let's ignore that. So if I wanted to do a command, let's say move, and you don't remember how to move, and you're looking for move everywhere and you don't see it, like if you don't remember that you can come in here and move, you can start typing like you would in CAD, and Rhino will try and fill in. It has this command line, and as you type, it's smart and it will fill in all the possible commands. And the more you use a command, the more often it will recommend that command at the top. So it starts to learn, the more you use it, what commands you like to use. So your most used commands will start getting suggested faster and faster. So for now, if I type in M, it gives you everything, and then M-O, and then see, it's starting to fill in move because it thinks that's what I want. And then you hit enter. And this is the key to, like, honestly, I would say like 90% of software is every time you click, see what the software is saying to you. Because a lot of people kind of like ignore the entire screen and just look at like the object that they're working on. But once I type to move and hit enter, you'll notice this changed and it became select objects to move. So it's trying to help you figure out what it needs. So I'm going to click that, and then it says press enter when done. So if you've ever like trying a new command, just go as slow as you can and then see what you want to do. So point to move from, and vertical equals no. If you click on that, vertical equals yes, that means it's going to move it vertically only. If you say no, then it'll say point to move from. We can click here, and now it says point to move to. We can click there, and then now you moved it. And the cool thing is, just like CAD, if you hit enter again to start a command, it will repeat the last command. So you can move it back now. And we can say move this guy. One thing to keep in mind, notice how it asked us to select the what objects do you want to move, and then you hit enter. If you already had something selected and we hit move, it doesn't do that. See, it just assumes that your selection is the object you want to move. So if that's correct, then that's good, but sometimes you'll do a command and you have something selected that you didn't know about and it skips the first part, and then you're like, it's not working, because it will ignore the fact that you had to go through the first step and just gives you that. It's trying to help you, but sometimes if you aren't aware of that, it kind of throws you off a little bit. The other thing that's really cool with Rhino is, up to now we've been just looking at like basic stuff, but the fundamental difference between Rhino and a software like SketchUp is the back end and how it draws geometry. So the standard geometry within Rhino is what's called NURBS. So rather than controlling a line like this, like AutoCAD does, or SketchUp, right? So you have a line and it's a connection of points, right? So see, there's like endpoints, and if I want, I can move that endpoint and move it there. And so my geometry is always going from point to point, right? And when you think of a 3D shape, it's the same thing. It's like a face to another face, and you're drawing exactly where you want that edge to be. Within Rhino, it can also do this, which is what NURBS is. I'm showing you in 2 dimensions because it's way easier to understand like this rather than in 3D. So I'm going to hit enter there. So now I drew this line, and notice where the points are. It's creating, think of these almost like planets with like gravity. So like as you get close to one, it'll start to pull towards that one, and then the other one will pull towards the other one. So these little points are what influence the shape of the curve, but they don't it doesn't have to flow through that point in order to complete the line. So that fundamental change is what allows Rhino to be so good at curved geometry, because now you can start putting like areas you would want the geometry to start getting near, and it can just start to average out those shapes. So you don't get like a perfect from here to here is 10 feet, and then it's going to be perfectly 11 feet, you'll get 10 feet all the way up to 11 feet and all in between, depending where you measure from, because it's going to give you those nice smooth curves. So as you're working, you can start to do this and move this like that. So if you've ever done a spline in AutoCAD, this is the same thing in 2 dimensions, where you have the different control points. Or when you'll see once we get into Illustrator, you can draw what are called Bezier curves, and that's exactly this, where you have control points and then the line is the path in between all the points. You can, if we start modifying this line, you can make it so that it actually starts going through the curve, not just around. So if you look, this one is similar, but these ones are actually always going to go through it. But the main difference here is you have these points of influence that are what's actually controlling it. So when we start to draw, you don't have to do this part, but once we start to draw 3D, and then you turn on your points, you can grab something like this, and then think of this, just like we had here where we moved these points and it changed the shape. Now you can start to do that, except it's going to average out all of this. So then we can grab here, oops, I keep getting stuff in the background. We can start to like blend parts of this, move this up, and so that makes it a lot easier to start deforming and drawing stuff like that, or to start making things like blend together. So what we're going to look at today is we're going to go through a series of exercises that show you that for the first part we're just going to make a box like 100 different ways, and then you'll see at first it's like no different than SketchUp, and you're like, man, like we could have done this in SketchUp, there's no big deal. But we'll get to a point where we have it set up so that you'll start doing things that in SketchUp would be really hard, but you'll see that in Rhino it's no harder to make a weird shaped box than it was to make the straight box, and the commands sometimes are actually exactly the same. So it shows you that there's a lot of flexibility within this. So does this make sense so far? Is everyone following along? Because that is like the most important part, that if you remember that it's like this instead of like that, it helps a lot, because there's these little floating points that aren't actually on the surface, but they do affect it. And the more you have, so see here how this looks like a piece of like cheese that's like melted all over. So if you have less control points, you actually get less control, and that results in a smoother curve. The more control points you have, the tighter your curves can be. Notice here I only have 3, and that curve is nice and long and smooth, whereas here I have like 5, and the curve can be really tight and twisty. So some people always take their shape and rebuild it and get like 100 sides, whereas if you just had like 3 in each direction, now if I turn on my points, you'll see this can be way smoother than that one ever will be. You don't have as much control, but the fewer points you have, the nicer and smoother your curves become. And that's something that the more you start modeling this kind of stuff, the more it will make sense. And at some point you'll need to have areas where you have more concentration than other areas. But I don't recommend trying to, because see, to try and make that curve with this many points would have taken me forever, because see, I'd have to grab this one and see what it does there. So like the more individual points you have, the more you have to like average stuff out. So now all this stuff, we can just get rid of it. And if you open up